Yeah, but you're gonna get shot too.
All right, today we're looking at using trig identities to simplify trig expressions. And we're doing a new unit, starting a new unit today, and a lot of today has to do with being able to make substitutions. Right? And that's where these identities come in. They're going to give you a bunch of different things that you can substitute something for something else. And that's what a lot of this unit has to do with, is making substitutions to simplify some type of expression or some type of equation. So we're going to look at three different trig identities today. The first two we should be familiar with. The third one will be new to us. So the first two types of, or the first type of identity is reciprocal identities. So reciprocal identities are the first ones we want to look at today. And we should be familiar with these, or they should come naturally to us. What is the reciprocal of sine? Not cosine.
The inverse?
The inverse.
No, what's the reciprocal of sine? Cosecant is
1
a
over sine.
reciprocal of sine. So that means sine is going to be equal to 1 over cosecant of x, since they are reciprocals of each other. That also means that cosecant is going to be equal to what?
Secant? Or sine?
1 over sine. So that means something we're going to be able to get used to in this unit is, if I have 1 over cosecant, I can replace it with sine, and if I have cosecant, I can replace it with 1 over sine. The one on the right is the one we're going to use most, or we'll use this one more than the other. When we see cosecant, we're going to want to replace it with 1 over sine. Okay, along those lines, what's cosine going to be equal to?
Secant.
1 over secant, which means that secant is going to be equal to 1 over cosine of x. And again, this one on the right is the one we'll probably use most. Anytime we see, or usually when we see secant, we would take secant out and replace it with 1 over cosine. Okay, and what's the last set of reciprocal identities? Tangent is equal to 1 over cotangent, and cotangent is equal to 1 over tangent. Those two we usually don't use that much. It's mainly those top two on the right of the reciprocal identities that we use most often. So when you see cosecant, be ready to replace that with 1 over sine. When you see secant, be ready to replace that with 1 over cosine. Those are your reciprocal identities. The next identities are called the quotient identities, and there are two of them. Quotient identities. What does the word quotient mean to you?
Division.
Some type of division. Okay. So they're going to be tangent equals something and cotangent equals something. What do you know tangent equals? That's a fraction. Say it again. I can't hear you. All right. And what do we relate to opposite? What trig function relates to opposite? What trig function relates to opposite?
The
Sine. And what trig function relates to adjacent?
cosine.
Cosine. Tangent is equal to sine over cosine. Because remember, if I know what sine is and I know what cosine is, what do we do to get tangent? Take the top of sine over the top of cosine. But technically what we're doing is we're taking sine over cosine, and the denominators of those two cancel out. So we shorten it to just saying the top over the top. But technically it's the whole sine over the whole cosine, but the denominators of sine and cosine are always the same, and since they're always the same, they're always going to cancel out. So I don't have to worry about it. So what's cotangent going to equal?
Cosecant over secant.
cosine over sine is what tangent's going to equal. Okay, and we use these quite a bit. We're going to go from the left side and to the right side. Is usually how we use those. Sometimes we'll go from the right to the left. Most of the time, 75% of the time, you're probably going to go from the left to the right. Okay, so that's reciprocal and quotient. Those you should be familiar with. The next one are the Pythagorean identities, which will be new to you. There are 3 sets of 3 Pythagorean identities. And what do you think the Pythagorean identities are based off of?
Three.
The Pythagorean theorem. What is the Pythagorean theorem? Okay, what do the A and B represent? Opposite and adjacent. So instead of using A and B, let's do opposite and adjacent. So let's do O for opposite, A for adjacent, and what does it equal?
Hypotenuse.
The hypotenuse squared, so we'll make it h squared. Alright, so there's my Pythagorean theorem. Opposite squared plus adjacent squared equals the hypotenuse squared. Now, we're going to do 3 different things to this identity here to get our Pythagorean identities. The first thing we're going to do is we're going to go in here and divide everything by h squared. So on the right side of this equation, what is h squared divided by h squared? 1. And let's go in and figure out what these things equal. What does O represent again? Opposite, and the h is hypotenuse. What's opposite over hypotenuse? Sine. So what can I replace O squared over h squared with? Sine squared. So that's sine squared. What does the A stand for?
Adjacent.
Adjacent, and the h?
Hypotenuse.
So adjacent over hypotenuse is cosine. So there is our first Pythagorean identity and the most important one. Sine squared plus cosine squared equals 1. Okay, and then there are 2 variants of this that we can find by subtracting. So if I subtract cosine squared over, the first variant is sine squared equals 1 minus cosine squared. The other variant is when I take the original and subtract sine squared over, I get cosine squared equals 1 minus sine squared. So there's your first set of Pythagorean identities. So the substitutions you're more than likely going to make with these 3 is if I see sine squared plus cosine squared, I'm going to replace it with 1. If I see 1 minus cosine squared, I'm going to replace it with sine squared. And if I see 1 minus sine squared, I'm going to replace it with cosine squared. Those are the moves that you're going to use with this information the majority of the time. Okay, so there's my first set. Let's move on to the second set. Alright, so the first time I divided by h squared. What's something else I might want to do? Nope.
Divide by O squared.
Divide by o squared. So obviously o squared divided by o squared is 1. Now let's figure out what a squared divided by o squared is. What's a squared divided by o squared?
Cotangent.
Cotangent. So this would be cotangent squared. And what is h squared divided by o squared?
Cosecant.
Cosecant. So that would be cosecant squared. So there's that one. And there are 2 variants off of this one. If I subtract cotangent squared over, I get 1 equals cosecant squared x minus cotangent squared. Or if I subtract the 1 over, I get cotangent squared x equals cosecant squared x minus 1. So there's my second set of 3. Okay, and the majority of the time, if we use these, we'll be taking this and substituting that. We'll be taking this and substituting that, taking that and substituting that. Okay. That's what we'll do the majority of the time when we use those identities. All right, and then what's the last thing we can do to this Pythagorean? Divide by a squared. So obviously a squared divided by a squared gives me 1. What is o squared over a squared going to turn into? Tangent squared. And h squared divided by a squared. Secant squared. So tangent squared plus 1 equals secant squared, another Pythagorean identity. And again, we can do 2 subtractions to get some variance off of this. If I subtract 1, it gives me secant squared x minus 1. Or if I subtract tangent, I get 1 equals secant squared x minus tangent squared x. So there is my last set of 3 on the Pythagorean identities. And again, majority of the time, we'll be taking this and substituting that. We'll be taking this and substituting that. Take that, substitute it for that. That's what we're looking to do. Now, I want you to look at all of your Pythagorean identities. And what is a common theme on all your Pythagorean identities? For the most part. And most of them have 1, and Kaylee. Most of them have 1, and it's either added or subtracted to what? Stevenson. Most of them have 1, and it's either added or subtracted to a trig function that is squared. So when we are working problems and we see 1 that is being added or subtracted to a trig function squared, that means we probably need to use what type of identity? A Pythagorean identity. So that is a dead giveaway that I probably need to look at a Pythagorean identity to see if I can make a substitution. Alright, so now let's use these. Alright, we've got 4 examples, and we're going to use the 3 types of identities we've looked at today to simplify these examples. So, first one. Cosecant x minus cotangent x times cosine x. Cosecant x minus cotangent x times cosine x. So I have a trig expression that I want to use identities with to simplify it. Now, a rule of thumb does not mean it's always going to happen, but a rule of thumb is if you don't know what to do to begin, you always want to turn everything into terms of sine and cosine. So if it's not sine or cosine, such as cosecant or cotangent, we want to use an identity to turn it into sine or cosine. And we either use our reciprocal or we use the quotient. So what can I take cosecant and turn it into?
1 over sine of x.
1 over sine of x. And what can I take cotangent and turn it into?
Cosine of x over sine.
Cosine of x over sine of x. Okay, so a rule of thumb is, if you don't know what to do, change everything to sine and cosine using a reciprocal or a quotient identity, which is what we did there. Alright, so now, what do you want to do next? Say it again. What do you mean by that, Rachel?
I mean that's going to be smaller.
Okay, so what's it going to look like? You know, can somebody help me out? What do you got, Kathleen?
Could you multiply the cosines together and get cosine squared and then just subtract 1 minus cosine squared over sine of x.
That is correct. Very nice. Okay. Notice we've got a fraction on the left. We've got a fraction on the right. Both fractions have what as denominators? Sine. So that means I can combine the numerators. I've got a 1 on the left, so I have 1 minus. I've got the 2 cosines being multiplied on the right, which gives me cosine squared. Very good, Kathleen. Now, something should be jumping out to us at this point. There's a square and a 1. I have a trig function that is squared, and I have a 1, which tells me I need to look where? A Pythagorean identity. Is there a Pythagorean identity I can use?
Yes.
Yes. What does this turn into?
Sine squared.
Sine squared. So I take 1 minus cosine squared out. I put sine squared in its place. And I can do one more thing to this problem. What can I do? I can reduce it, and I end up with sine of x. Everybody understand how we go from sine squared over sine to get to sine? Okay, just like if I had x squared over x, what does that reduce to? X. Same thing here. I've got sine squared over sine reduces to just sine. So we started with the trig expression. We used our trig identities to simplify it all the way down to sine of x. So that means this whole thing up here, this trig expression I started with, what does that equal to? That is the same thing as sine. That is correct. Okay, that's the kind of stuff we're doing. Let's try the next one. Alright, on this one I have cosecant times cosine plus cotangent over secant times cotangent. Cosecant times cosine plus cotangent over secant times cotangent. So I want to use my trig identities to simplify this trig expression. So, what do you think? Any suggestions? And that's the thing you got to get used to in this section, in this unit, is you have to be willing to try something and be willing to be wrong. If you're not willing to try something, then you're just going to be stuck and you'll never get started. You have to start and be willing to be wrong and start over. Matthew.
Let's start making cosines and secants. Or sine and cosines.
So turn everything into sine and cosine.
Yeah.
So I want to replace that, replace that, replace that, and replace that. I want to replace those right there. So what's cosecant going to be replaced with? 1 over sine. And cotangent is going to be replaced with cosine over sine. Down here on the bottom, I'm going to have a 1 over cosine, and then I'm going to have a cosine over sine. So I made substitutions using the reciprocal identities and the quotient identities. Now what?
Now you can combine things that you want.
Okay, so in the numerator, what does the numerator end up being?
So 2 cosines of x.
2 cosine over sine is what my numerator ends up being. Does everybody see that? Because this is cosine over sine, this is cosine over sine. So when I add fractions together, what part of the fractions do we add? The numerator. So cosine plus cosine is 2 cosine, just like x plus x is 2x. So if you get confused on what you need to do with your trig functions, take the trig functions out, put x in its place, and ask yourself, what would I do with the x's? Whatever you do with the x's, that's what you want to do with the cosines. Okay? All right, on the bottom, what happens on the bottom?
It becomes 1 over sine.
All right, these cosines cancel, and I get 1 over sine. At this point, we run into something that we're going to run into quite a bit, and that is we have a situation where we have a fraction inside of another fraction. Whenever you have fractions inside of a fraction, I recommend that you, and it's kind of confusing to say, I recommend that you multiply by the denominator of the fraction within the fraction. So in this case, what would that be?
Sine.
Sine. So I want to multiply top and bottom by sine. Now there is another method you could use, but this is the one I prefer because it is successful most of the time. Most kids like this. So on the top, what happens when I multiply? Those signs cancel, and on the bottom, those signs cancel, so the only thing I'm left with is 2 cosine of x. Now, what is my other option besides multiplying by sine over sine? Multiplying by the reciprocal of the denominator. I can multiply by the reciprocal of the denominator and achieve the same result. But I prefer multiplying by the denominator of the fraction and the fraction. So we have just taken this trig expression up top, and we have used our identities to simplify it down to 2 cosine. So that trig expression at the top is equal to 2 cosine. Next one, 2 more. Alright, cotangent of x minus cosine cubed of x times cosecant of x. Cotangent minus cosine cubed times cosecant. That is correct. So we want to start out by making substitutions to get everything in terms of sine and cosine. So the cotangent turns into cosine over sine. Leave the cosine cubed alone, and the cosecant turns into 1 over sine of x. Now, I can combine them. Why? We both have the same denominator, so that means I'm going to have sine on the bottom. And what's my numerator going to be?
Cosine x minus cosine cubed.
There we go. Cosine x minus cosine cubed of x. And let's see what kind of vision we have on what we need to do next. Let me ask you this. If you had x minus x cubed, what would you do with that? What? I would take out an x. Very good, Hunter. So what am I going to do over here? Take out a cosine. Outstanding, Hunter. If I take out a cosine, what's in the parentheses?
Oh,
1 minus cosine squared. And the bell should be going off because what do we see?
Really familiar.
We see a 1 and we see a trig function that is squared, which tells me to look at what identity? The Pythagorean.
Sine squared.
Sine squared. So I have cosine times sine squared over sine. Which just ends up being what?
cosine x minus
Oh, and then we know how to do that. That's fantastic.
So we end up with just cosine times sine because one of the signs reduces. So we took that original trig expression, we used our identities to simplify it down to cosine times sine. One more. This one's a little bit more involved. I have 1 minus cosine over tangent plus sine over 1 plus cosine. So hopefully you notice that this one starts out a little bit different than the other three did. You would think that, but in this situation, with the way it starts, we don't want to do that just yet. We eventually do, but not yet. How is this problem different than the previous three? It starts out as fractions. If your problem starts out as fractions, what do you think you want to do first? Get a common denominator is what we want to do. So if your problem starts out as fractions, you want to get a common denominator first. So what is my common denominator?
Tangent x times 1 plus cosine.
Very good. Tangent x times 1 plus cosine of x. So what do I need to multiply this fraction on the left by?
1 plus cosine of x.
1 plus cosine of x. So when I multiply these two right here, I need to notice what is it that we're dealing with. What are those called?
Oh.
Right? What's the term for it? Starts with a C. Conjugates. They're conjugates. What do you do with conjugates when you're multiplying? What do you multiply? First and the last is all you have to multiply. So I need 1 times 1 is 1. Cosine times cosine, negative cosine squared of x. What do I need to multiply this other fraction by?
Tangent of x.
Tangent. So that gives me plus sine of x times tangent of x. So if you start out as fractions, you get a common denominator, put them together. Now we've got something we're dealing with that's similar to our other three problems. So what do you want to do next? Make everything sine and cosine, but does anybody see anything in the numerator? Yes, Bobby.
There's a square.
There's a squared and there's a 1 in the numerator, which tells me there might be what? A Pythagorean identity. What Pythagorean identity is up there?
Sine squared.
This right here is equal to sine squared of x. Okay, what do we change tangent to? Sine over cosine. On my denominator, I change that tangent as well. Sine over cosine. And leave that 1 plus cosine of x. Now what?
Multiply by the denominator.
Very good. So what am I going to multiply by, Blake?
Cosine.
No.
No, but.
Yes, you're right. You're right.
Oh,
Sorry.
okay.
You're correct. So I'm going to multiply by cosine. So what does my denominator end up being?
One plus
Very good. Sine of x times 1 plus cosine. The numerator's a little bit trickier. What does the numerator end up being?
Sine squared times cosine x plus sine squared.
Very good. So sine squared cosine of x plus sine squared. Because when I take this times this, the cosine cancels. When I take this times this, I get sine squared cosine. All right, now what?
Take sine from the problem.
What do you mean?
Well, you can divide by sine.
Right, but I'd rather you do something else instead of divide by sine before I do that. What did we do on a previous problem? What did we do? Which one was it? I think it was the one before. There we go. Take the sine squared out. I prefer you take it out before you cancel it. So if I take that out, I get sine squared x. I get cosine x plus 1 over sine 1 plus cosine. And then some good things happen for us.
We're
What
just
happens
left
for
with
us?
sine x.
The sine x is reduced and the cosines do, so I end up with just sine. So So we took that 1 minus cosine over tangent plus sine over 1 plus cosine. We used our identities and we got it all the way down to sine. So that's what we're doing, using our trig identities. What 3 types of identities did we look at today? Pythagorean, reciprocal, and quotient. We used those identities. We made substitutions to simplify trig expressions. Okay, most of the time, what are we going to do to start with? Change everything to sine and cosine. Anytime I see a trig function squared and a 1, usually Pythagorean identity. What if I start out with 2 fractions being added or subtracted? Get a common denominator first. There we go. Very nice. Alright. And again, you have to be willing to be wrong. On these problems, you've got to be willing to try and fail. If you're not willing to try and fail, then you're not going to get good at it.